Alright guys, so we're going to pause and take some notes essentially on some arithmetic patterns and talk about some recursive equations a little bit more in depth. Make sure you guys know what's going on here. Okay, so you probably want to have some notes of some sort out there. Jot down some of this stuff. Okay. Also, if there's anything you need a little bit more time to write down, please inform the guest teacher so that they can pause it for you so that you have enough time to get all this stuff written down. Okay. So let's jump into them. Okay, so we've been talking about patterns and these sequences, okay, how these numbers are growing, these patterns, okay. So when we talk about this, okay, within recursive, and again, these are this is the recursive equation style. Next time we'll go over explicit. But the idea here is that in order to get the next term, right, if we're looking at a table, so we've got our first term, maybe it's 10. Second term, maybe it's 13. Third term, what is that going to be? Okay. Well, to find that next term, that third term, we take that previous term, so we're going to take 13, and we're going to apply the growth, the pattern, okay, which 10 to 13, we added 3. So the pattern would be adding 3, okay. So we add 3 to 13, and we get 16, okay. So that's what those stand in. Now, when we talk about them in the recursive formula, we use a sub n to refer to these outputs, okay? So that next output, say we want to get number 4, so a sub 4. Remember that number down here, the subset number, is just which term we're dealing with, okay? Which n we're dealing with. So we're dealing with the fourth term. Well, how do we get the fourth term? Well, we need the previous term, the third term, right? We need this guy, or n minus 1. 4 minus 1 is 3. And then what are we going to do? We're going to apply that growth to it, okay? That add 3 and get 19, okay? Now, in order for this to work, we also need to have the first term, okay? So, again, previous is just represented by a sub n minus 1. Next is represented by a sub n. Okay, that growth, it's just we call it a common difference or constant difference. I like to call it growth. Okay. All right. Now, the other thing with a recursive is just knowing that something is adding 3. Well, that could be a ton of different kind of patterns. Okay, just that adding 3 could be multiple different patterns. So we need to know where our first term is, okay? Now, we say first term, and really, I shouldn't say first term. I should say 0 term, okay? Because the first term would be that guy right there, and we don't want the first term. We want the 0 term, the beginning term. So let's rewrite that as beginning or starting. And I'm writing begging. I think I did that earlier. Okay, we want that term where we begin. Okay, so in this case, it would be 7, right? Because 7 plus 3 would equal 10. So we have to know where we start in order to know how we can change, okay? And the sequence notation we use, which is right here, okay? But let me show you an example from ours, okay? So I go a sub n, the next term, is equal to a sub n minus 1, the previous term. And what did we do? We added 3 to it, okay? Then a sub 0, where do we start? What's our beginning number? It was 7. That right there is my recursive equation. Okay, it's 2 parts to it, where it starts and how it's growing. Okay. Now another way we can talk about it is using function notation, and it's pretty much the same thing. F of n is instead of a sub n, and instead of a sub n minus 1, f of n minus 1, but we still put on the growth. Instead of a sub 0, f of 0, we still put in our starting number. Okay, that's another, and we'll get more into that later. But right now, we're more focused on just looking at this recursive style of doing things. Okay, so now the thing to note on every one of these parts, we have this the same every single time. That's always going to be the same. Okay, we always include that part. The only parts that are different are the growth, the common difference, and our starting number, okay, our beginning number. Alright, so let's kind of take a look at some patterns and stuff and do this. Okay, and see. So again, before I look at anything else, I can write down this part of my equation. Okay, because I know that part's always going to be there. And then I just have to find those pieces. Okay, I know it looks weird, but again, it just stands for, to get my next term, I take the previous, and where did I start? Okay, so looking at this, looking at number of matchsticks. So on the first term, we have 3 matchsticks. Okay, that's not our a sub 0, so don't put it right there. That would be technically our a sub 1. Okay, then pattern 2, we have 1, 2, 3, 4, 5. Pattern 3, 1, 2, 3, 4, 5, 6, 7. Pattern 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so hopefully we see how are we growing. Our pattern is growing by 2. Our common difference is 2 each time. Okay, so if I was looking for pattern 5 or pattern 6, I take that previous number and I add 2 to it to get 11 and then 13. So that growth, that plus 2, goes right here. So I have a sub n equals a sub n minus 1 plus 2. Okay, now a sub 0 is not 3 again, so we got to work backwards to what the 0 would be, right? This would be a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. So a sub 0 we work backwards. Well, the opposite of adding 2 is subtracting 2. So I take 3 and subtract 2, and we'd have 1 matchstick. So that's what I put for my starting number. And that's my equation. Okay, again, it needs both those pieces in order to work. Okay, but the a sub n equals a sub n minus 1, always going to be there. A sub 0, always going to be there. Again, stands for, that's my beginning, that's my next term, that's my previous term. Okay, that's all it takes. So let's take a look at another example here. Okay, in this case, we're looking at number of chairs. So, in our first configuration, we have 4, 5, 6 chairs. Then we have 1, 2, 3, 4, 5, 6, 7, 8 chairs. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chairs. Again, our growth is adding 2. So again, I know a sub n equals a sub n minus 1. And my growth, so I put a plus 2 on it. Okay. Then I need my starting point, my beginning point. So if I go backwards to the 0 configuration, we would get rid of 2 of those chairs, right? And we'd have 4. So I'm starting with 4. So that tells me if I'm making a table that my beginning term is 4, then each one after that I'm adding 2. And I can create that pattern, okay? Again, the only things that change is our beginning number and that common difference, or in other words, how it's growing. All right? So, and we can do it even if we're just given a set of numbers, okay? The way to think about this again is 31's our first term, 41's our second, third, and fourth. So that common difference we can see is going to be, we're adding 10 each time, aren't we? So plus 10. So if we go backwards to our 0 term, it's kind of like we're making a table here, isn't it? We'd go back by 10, and that would be 21. So we start at 21. So again, I know I'm going to go a sub n equals a sub n minus 1. And then we add 10 to that. That's how it's growing. Where did we start? A sub 0. That was 21. Okay. And that's all it takes for us to create these recursive equations with patterns. Okay, so let's take a look at 2 more examples on these ones, or maybe more. Okay, so again, if I'm moving too fast, just ask the guest teacher to pause this and go back if need be, and make sure you're able to copy down some of these examples and these notes. Okay, so there's nothing wrong with needing to take this extra time to do that. So again, okay, we've got negative 25, negative 55, negative 85, negative 115. Again, that's our first term, our second term, our third term, our fourth term, to figure out the fifth term. How's it growing? Well, hopefully we can see that we are subtracting 30 each time. So that'd be negative 145, right? So we're subtracting 30 on each of these. So if we were to go backwards here, okay, we should realize that's going to be a positive 5 for our 0 term. Okay, because 5 minus 30 equals negative 25. Again, I go a sub n equals a sub n minus 1. Put my common difference, my growth, minus 30. Then, where did we start? A sub 0 was 5. Okay. Now, if you really wanted to, you could put a sub 1 and start with that term. Okay. And instead of a sub 0 equals 5, put a sub 1 equals negative 25. Or up here, instead of a sub 0 equals 21, a sub 1 equals 31. It would work in these cases. Thing is that a sub 0 will be more useful later on, okay, when we're dealing with explicit equations. So that's why I like to just use that. All right, so taking a look at the next one. So I've got my first term, my second, my third, and fourth. How's it growing? Well, it looks like I'm adding 30 this time instead of subtracting 30. We said subtract 30 last time, didn't we? Yeah, we did. Just having a little bit of a memory issue. Okay, so going back to my 0 term, it's got to be negative 47, because plus 30 would put us at negative 17. So again, I always write a sub n equals a sub n minus 1, and then put my common difference, how it's growing, that pattern, plus 30. Then my a sub 0, where did I start? We started at negative 47. Okay, so not too bad, right? When we have a pattern, when we have a sequence of numbers. Okay, now what about if we have a story problem? Okay, same idea. Where did we start? And what's our common difference? How's it growing? Okay, if we have those two, and if we need to, make a table and say, Sorziana is saving up for college. She already has $2 in her bank account. Okay, so she hasn't started saving. She's already got $2. Her job pays $10 per week. So we would be able to add $10 each week, right? So after week 1, she'd now have $12. After week 2, she would now have $22. After week 3, $32, right? So again, we started with $2 in the bank. We're adding 10 each time. That's our common difference. So a sub n equals a sub n minus 1 plus 10, and a sub 0 equals 2. Okay. So the next one. You run a business making birdhouses. You spend $600 to start your business, and it costs you $5 to make each birdhouse. Okay. So we started out by spending $600, right? Now you could put 600 or you could put negative 600 if you're saying, well, it's already spent, so it's negative. Okay, and how's it growing? Well, every time we make a birdhouse, it's going to cost us $5. Okay, so we're just simply talking about the cost. So our common difference would be $5, or if we're thinking money in the hole, negative 5. So there's kind of two ways that you could write this equation depending on how you were thinking. Okay, so then again, a sub n equals a sub n minus 1, and I'm adding 5 each time. Then a sub 0 would equal 600. And that would tell me how much I cost just altogether. If I wanted to go how much do I owe, essentially, it would be a sub n equals a sub n minus 1 minus 5, and a sub 0 would equal negative 600, depending on which way you wanted to think about it. Okay, but either one of those would work. But again, I always have these same pieces. Always, always, always. Okay, so let's take a look at two more. Let's actually pause and see if you guys can figure this one out on your own for a little bit. So let's give you like 5-10 minutes, have the guest teacher pause this, and then we'll take a look at it. So take about 5 to 10 minutes, try these two problems out, okay? So pause it right now. Alright, so hopefully you tried that on just a scratch piece of paper, kind of thought through. Again, I know right off the bat, it's going to be a sub n equals a sub n minus 1 and a sub 0. Okay, equals. So I could write that without even looking at the problem because I know those parts are always involved in my recursive equations, okay? So then, let's find out, where do we start? What's our zero term? And what's our common difference? How's it growing? Okay, so you make a $15 payment on your loan of $500 at the end of each month. So I'm starting $500 in the hole. That's my zero term. So I can put it down here. And every month, I'm making a payment of $15 on it. So I'm adding $15. Okay, so I add $15 each time. Okay, now using this recursive equation, right, we could make a table and figure out, you know, how many months would it take me to then, you know, get rid of all my payments, basically pay all that money back. And we can chart that growth based on that pattern. Okay, so that's how your recursive equation should have looked for that first one. Okay, now for this second one, again, where did we start? What's that zero term? And what's my common difference? What's the pattern? You're saving for a bike and can save $10 per week. So I'm going to be saving or adding $10 each week. Okay, that's my common difference, which would go right up here, right? You have 25 when you begin saving. So there's my start. So we start at 25, and there we go. And then again, depending on what I need to figure out, I can then use that information to help me figure out that pattern. Okay? So there's some notes for you guys. Again, if you need to go back to any part and copy any of that down, that is great. Do that. If not, I believe I have an assignment where you're going to do kind of the same thing. You're going to have story problems, picture patterns, and some sequences, and you need to create those recursive and explicit equations. And again, remember, we always start out with this part and this part, okay? And then depending on how it grows, that's what we put right there, and where it starts, that's what we put right there. So that common difference, how it's growing, goes right in there, and then where we start, what that zero term is, goes right there. And that's all we got to do for these recursive equations, formulas, whatever you want to call them. Also, I do have a video up for that homework, so if you have time in class and everybody seems to be done, or even if people seem to be struggling, you can play that video and kind of take a look, check your answers, see how you did, and that's pretty much all we got. So there you guys go.